Hello everyone, my name is Mike Petty and I am the Vice President of Sales with Thermal Imaging Radar. Our product, Thermal Radar, is the topic of today's webinar. I'm going to walk you through our product and tell you all of the great unique things about Thermal Radar. First of all, the company has been around for 8 years. We started in 2012. This product is made in the United States of America. We started in 2012, and the first thermal radar was developed and put into the marketplace in 2014. In 2014, we won several big awards. We won the ASIS Accolades Award for the ASIS International Show in Chicago. We won Popular Science Magazine, which is a very special magazine in the United States for new inventions, and we won the Best Security Invention of 2014. We also went to the largest security show in the United States called ISC West, and in 2014 we won the Best Imaging Product. We also won an award called the Utah Innovations Award for the state where we manufacture thermal radar. And then we went back to the ISC West show in 2017 with a little bit of a new product called the Hydra. And we won the Best Imaging Product and the Judge's Choice Award for Best Overall Camera System and Imaging Product at the show. I'll talk a little bit more about the Hydra later. So I'd like to discuss Thermal Imaging 101, or the basics of thermal imaging. Thermal imaging cameras can produce a clear image in darkness. Thermal imagers calculate infrared radiation released from an object, and then they translate that to varying temperature variations, and they do that into a color scheme. Some are in a gray scale, and others use bright colors. For thermal radar, we typically use a gray scale. So as you look at the thermal image here on the right, you can see several things that are unique. You see these trucks here that are lined up. Now the truck that's closest to us, the engine does not look hot. It's not white hot. So I know that that truck has probably been there overnight. Also, you can see underneath it, there's cool temperature on the pavement. Now the cars next to it have hot white engines. And so those cars are probably very new to parking right there. They've probably been out on the road. Now also I see a water puddle or an oil spill right here that's probably cool because the temperature of that is a darker black color, which in our scale means that it's cooler. Now the person we're detecting here, you see the person, as the person is walking across the pavement, they are changing the pixels as they move. So the pixels have variations as the person proceeds and disrupts the pixels, almost like a wave in a very still water area. So there's a lot of factors that go into thermal imaging. It depends on the size of the target. It depends upon the size of the lens you're using with your imager. Is it a cooled or uncooled sensor? The sensitivity of the sensor? A lot of different things that matter in the thermal imaging world. One of the ways that I've found to illustrate our take on thermal imaging and how we do our analytics to detect objects is this image. So this is an image of Abraham Lincoln that was a president of the United States many, many years ago. And President Lincoln has, in this picture over here on the left, we've digitized the picture into a gray scale. So we're using white and black and various shades of gray to pixelize the picture. Now, if you consider that all of those pixels have a variant of heat, so the black pixels are very cold, the white pixels are very hot, and the gray pixels are various shades of gray depending on what temperature they are. The middle picture shows that we have applied a numerical value to each one of those pixels. So you can see the very black ones, there's a 10, there's a 6, there's a couple of zeros in there, and those are going to be the very cold parts and pixels. Now you have very hot pixels. You've got a 236 and 236 and 252. So those are going to be hotter pixels and everything in between. So the way that our thermal imager sees that any kind of a scene or a field of view is really the picture on the right. We see the numerical values of the pixels based upon how hot each pixel is. So when we start to see those pixels changing significantly, so for instance, you have a 6 and a 10 and a 62 and a 33. If those 4 pixels all of a sudden went up and started increasing in heat, we would say, okay, there's something unique happening right there. And that's how we do the detection using pixel change. Now, it could be change for the hotter or change for the cooler. For us, we're looking for pixel change. So what makes thermal radar incredibly unique, we are a thermal camera. We use a FLIR thermal sensor, a Boson sensor in our thermal radar, but this is what makes us unique. We rotate the thermal sensor, so you're maximizing the capabilities of the sensor. So we're ostensibly getting 16 thermal cameras out of one device because this camera is stopping in every field of view as it rotates. So what I mean by that is we have fields of view that we call stops or stations. So when the camera rotates to station number 1, then goes to number 2, then 3, then 4, then 5, etc., the camera is actually coming to a complete stop, and we're stopping the camera or the sensor for a millisecond to take a good, crisp, clear image of that field of view. So the thermal sensor is continuously spinning and taking images of every stop. Now, to show you what the thermal sensor is actually seeing, this is what the thermal sensor is seeing as it looks out. Every one of those images is being analyzed in real time. Every one of these images in a thermal sensor like this has 327,000 pixels that we are able to analyze in a millisecond and generate an alarm based upon a detection. Let me play that for you just another second so you can get a feel for how fast that sensor is turning and how much data we are processing to look at every single pixel. Pretty amazing. So when we spin the sensor like that, it would be probably very difficult for someone to keep up with the sensor and watch it all the time. So we display the camera feed out of a thermal radar through this graphical user interface. So this GUI shows you 180 degrees across the top and 180 degrees across the bottom. You'll notice that this sensor has 16 stops or 16 fields of view to do a full 360 degree area. So that means that we have to stop the sensor 16 times in the 16 different fields of view to get this image. Now, every one of those 16 tiles on the top and the bottom will update with a new image every 2 seconds. So every 2 seconds, there's brand new images in all of those pixels. Now, when we detect something, like the guy that's moving here on the sidewalk, you'll notice that we're actually detecting him down here in the lower right area where I'm circling my cursor. So you see him being detected here. So we grab this stop or station and we move that into this middle section as an alarm area. So this middle section is always going to be your alarm area. We then are able to show where all of the detections are showing up on a geospatial map, on a Google Earth map. So you can see that we've got a truck being detected up here in station 7. I've got a person down here in 13. I've got this person in this station. And there are actually some other people under this building in the shadows you can see. So we're detecting 5 objects out there, and we're showing those with 1, 2, 3, 4, 5 location points on a map. What we're doing is we're actually measuring from the thermal radar to the target, measuring the pixels to the target, and then we can give you a GPS location. So that's where the name radar comes from. We're not technically a true radar where we're sending out radio waves that bounce off a moving target and come back and give us that reference. We're actually a passive system that's looking for the heat of an object that's moving and then calculating the distance to that using some algorithms that we developed. Okay, so this is the camera feed from a thermal radar. This is what would flow into your video management system, It's a very unique layout to show you the full 360 degrees in thermal in one image. As I said before, there are 5 models of the thermal radar. We have 2 models that are lower resolution sensors. So they're 320 by 240 sensors. These sensors are great. They do great detection of humans and vehicles out to human detection about 100 to 250 meters out on these two. This one's 150. But once you start getting beyond 200 meters of detection required, then we suggest you go with the higher resolution units that have 4 times the amount of pixels. So these higher resolution units can detect a person in the very best case scenario, 500 meters in radius. So 1 kilometer in diameter. Now, the detection distances also have to be considered with environmental conditions. The environment can impact thermal sensors and how far you can see and detect with them. So, for example, humidity and rain can decrease the detection distance of a thermal sensor. And not just our thermal sensor, these are FLIR sensors. So it's any kind of a thermal sensor has a variant because of environmental conditions. So I always want to make that point that just because we can detect a person at 500 meters in the very best case scenario, it's usually going to be somewhere between 225 and 325 in radius as far as meters. So that's always something to consider when you're talking about long range detections. And for vehicles, yes, although we can hit at 1500 meters in the best case scenario, I typically plan on hitting vehicles somewhere between 750 meters and 1,000 meters. So with our longest range sensor. So let's talk a little bit about what we're actually looking for. We talked about it earlier when I showed you the full 360 view, but here's a person that's walking outside of a fence line. They're about 157 meters away from the sensor. We're detecting them on the map, and so we're scanning a wide area looking for exactly that, some random person in a place where they probably shouldn't be, because thermal radar is typically used in areas where no one should be. For instance, one of our big markets is the power grid and power substations, or crude oil transfer stations, or natural gas transfer stations, or border security. All of these are places where really nobody should be in these areas, and thermal radar is there to look for anomalies. Thermal radar is not a great use case for downtown New York City because, number one, the buildings would block your view and there's lots of people moving around. So thermal radar is good for open areas, and that's primarily the kind of areas we service. This is a great image from our thermal radar. You can see the trucks and the buildings and the trailers, but what you're not seeing is what the sensor is picking out. That person that's standing on the corner of the building. You see that? That person is being detected. They're there in both pictures. And the thermal sensor is sensing that the pixels have changed right there, and we're detecting that person standing on the corner. So it's a pretty unique solution. So this is a kind of an exciting slide. This is our Hydra. This is a thermal radar that's combined with a pan tilt zoom camera. So we can work with Bosch cameras, Axis cameras, Hanwha cameras, Hikvision, whatever the PTZ camera is that you would like to use. What we like to tell our customers is use a pan tilt zoom camera that has long range IR capability so that you can have the PTZ camera see in the dark. Because if thermal radar can detect a person at 300 or 400 meters and the IR of the PTZ can't reach that far, then that becomes a problem to confirm what the thermal radar is detecting. So in this sense, this L-shaped building that you see here, we've mounted the thermal radar Hydra on the corner of the building. So from the corner of the building out to the edge is about 300 meters. You can see the roadway here and some of the cars and the big trucks passing on the roadway. This is a very big equipment yard, and we're covering the entire yard with just one thermal radar mounted to the corner of that building. So that's really where the value of thermal radar, I think, comes in, is that it's, in most cases, it's a single camera solution where other solutions might have to have 10 or 15 cameras or 20 cameras to do the same thing that we're doing. This is another great picture as far as distance and capabilities. This is the United States Pentagon. It is our Department of Defense building. So if I were to put a thermal radar in the middle of the courtyard and the building wasn't there, the red circle is my detection distance for a human being, for a person in a best case scenario area. So again, I don't always say that we're going to hit every time at the 500 meters that I talked about earlier. Again, I usually say with our longest range sensor, 250 to 300, 350 meters is something you could plan on pretty regularly. So this is a great video I'm going to show. We were doing a demonstration for a customer, and we had the camera set up at a natural gas transfer station. So I'm going to show you this video. It's of me. I'm actually walking the perimeter, and the thermal is detecting me. And every time you see the pan tilt zoom camera move a little bit, it's because thermal radar is giving it a command to move. So thermal radar detects me, tells the PTZ camera to move a little bit. So as I go behind the building, I'm now out of view because we're a line of sight device. All of a sudden, the PTZ camera moved, and our customer could not understand why the PTZ camera moved. And here came a random person walking up the other side of the property that we detected, and we moved the PTZ to the target. So here comes the person. He was not part of the demonstration, and he came in, and then he disappears through a hole in the fence that the customer did not know about. And then the thermal radar redetects me coming out and is following me again. So our ability to detect multiple targets in different directions is there. It's almost like there's nothing that we cannot see if it's within our range. We detect and see everything that we need to be seeing out in the environment. I'm going to go to this slide. This is a wide area intrusion detection and surveillance slide for what we would call a traditional system versus thermal radar. And I show you this slide because I think it's very powerful. Thermal radar is not an inexpensive camera. It's an expensive camera system. But when you compare a thermal radar to another type of installation, the installation I'm going to show you is a small airport. And this small airport is going to take 55 fixed cameras. They could be FLIR cameras or Axis cameras or other brands of cameras. But at $3,000 to $5,000 per camera, it gets very expensive. And if you factor in, 8 to 10 pan tilt zoom cameras, but it's more important to this is the infrastructure cost. If you have to wire and trench and network 55 thermal cameras and 8 PTZs, it could cost a lot of money. $800,000, $1 million to do this kind of a site, this small little airport I'm showing you. So all of those perimeter cameras you see are going to be FLIR cameras or fixed thermal cameras. Again, there's 55 of them. And with a thermal radar, you're getting a little bit different approach where we're only using 4 of our Hydras. We don't have to do much critical infrastructure improvement because you're only putting in 4 cameras, and our estimated cost of the project is far less. So we put in 4 thermal radars and we do this. So that's where the power of our 360 coverage area comes in. And again, not having to wire the entire property for a whole bunch of other cameras. So these are a few of the installs that I wanted to show. We have very specific brackets that we manufacture because the bracket has to be able to hold the thermal radar on the top so that it has a good clear vision area, and the PTZ on the bottom. Now the PTZ is going to have a very small blind spot based upon what kind of a pole you're mounting to. With our gooseneck, it's a very, very small, maybe a 5-degree area that it may not see because of the pole. But we found that this type of bracket is really helpful for us to get a great thermal coverage area and followed up by the PTZ moving around. So just a couple of nice pictures of some of the installs that we've done. We work all over the world. We're in Asia, we're in Africa, we're in Europe, we're in the Middle East, We're in South America, Latin America. So these are all projects and installs that we do everywhere. Now, because our thermal radar wants to sometimes be used as a remote solution, we make a trailer system. So this is a mobile trailer with solar panels and a 4G router and a VMS platform. Everything is inside the trailer. So this is the kind of solution where you can literally drop the trailer, fold out the panels, start it up, do configuration. We can have this unit set up in about 30 minutes, and then it's totally autonomous. It will just run and detect and move the PTZ wherever it needs to go. So this is a unique solution that we also make. We do a lot of these in the United States, a lot of them in Latin America, and it's proven to be a very, very powerful remote solution. So I hope this webinar and this information has been valuable and informative to you. Thermal radar is truly a unique solution. It is unlike anything out in the marketplace. The analytics that we do are on the edge. We have truly the most capability that any thermal camera could have because of our view and because of the analytics that we do. So I hope you find this, again, informative. If you have questions, you can speak with your integrator, or if you'd like to reach out to us directly, you can go to thermalradar.com, or you can reach us by email at sales, S-A-L-E-S, at thermalradar.com. That is sales at thermalradar.com. Well, we hope to speak with you soon, and hopefully we can quote a big project and do some work together. Thanks. Have a great day.